Hi, in this video we will use integration to find a general solution to a differential equation. Now going forward we're going to talk more and more about how to solve differential equations, but the main thing you need to keep in mind is pretty much we want to get all our y's on one side, all our x's on the other, and that includes our dy dx. So what I'm going to do is multiply each side by dx, okay, or in other words I'm going to move this over here. So now all I have left on the left hand side is the dy, and on the right hand side I have 6x squared dx. And now I can integrate both sides to find a general solution. The integral of dy is just going to be y. Sorry about that. And the integral of 6x squared is going to be, well, x squared becomes x cubed. Okay, so this is going to be y. This is going to be x cubed over 3. So this is going to be 6x cubed over 3. Okay, and then I have to add my constant, okay, because it's a general solution. And I can simplify this here. So it's going to be y is equal to 2x cubed plus c. Let's try another one. In this one, same thing. I want to get my dy isolated over here. If I had any y variables, I'd want it to be over here as well. We'll talk about that in some later videos. But for now, just think about multiplying each side by your dx, or just moving your dx over to the right hand side. Over here, I'm just left with my dy, and over here, I'm left with sine 2x dx. And now I'm ready to integrate both sides to find a general solution. The integral of dy, again, is just y. And over here, I get the integral of sine 2x, okay, which I need the derivative of this part. So the derivative of 2x is 2, so when I have the 2 dx. And when I do that, I need to have the 1/2 out here. Okay. All right, and now with that in place, this is going to be the integral of sine 2x is just going to be minus cosine 2x. So this is going to be minus 1/2 cosine 2x, but again, I have to add my constant. All right, and now for my last example down here, for the third and final time, I need to get my dx on once away from my dy. So again, I'm just going to move that over. And that would dy equals 5e to the minus x over 2 dx. Once again, I'm going to integrate both sides. Okay. I need to make sure I have the derivative of e to the u, whatever the derivative of the exponent is here, which it would be negative 1/2. So I'd have negative 1/2 here. So I need to multiply by minus 2 here. Okay. The integral of dy just becomes y. I have my negative 2, and now the integral of e to the x is just e to the x, so this is going to be 5e to the x, okay? Or in this case, the minus x over 2, and then add my constant. So y in this case would be equal to negative 10 e to the minus x over 2 plus c. I hope these help.